Good morning, students. I am Dr. G. Chinnara. Today I am going to explain PCNF and PDNF by truth tables. Okay. To construct PCNF or PDNF, you have to learn min terms and max terms. When you have two variables, then we have two square min terms as well as two square max terms. So min terms consist of conjunctions in which each statement variable or its negation but not both. It means when you have two variables p, q, its min terms p and q, negation p and q, p and negation q, negation p and negation q. So these are min terms. So max terms are P R Q, negation P R Q, P R, negation Q, negation P R, negation. These are max terms. But P and negation P are Q and negation Q reject, because as per the definition, conjunction of the variables are negations but not both appear in this context. Okay, by using this definition we can construct PDNF as well as PCNF. So to construct PDNF, PDNF is the disjunction of min terms. Now to construct PDNF you have to form truth table. Okay, we know very well about to construct truth table. After finding truth table you also find min terms. Okay, so how do you get min terms? Its combination is true. When will you get true? Both PQ are true, then its conjunction is true. Otherwise, it is false. So P and Q and R is true. Only P is true and Q is true and R is true. Okay, but in this case, P Q true but R is false. To get their conjunction is true, we have to make R to be true. In that case, P and Q and negation R, then we will get true. In this way we can get min terms. Okay, after writing min terms you have to round up where you get true. Here we get four truths: true, 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 true. Okay, after rounding truths, to write PDNF, take their combination and write the disjunction of these min terms. So PDNF of this is P and Q and R, or P and Q and negation R, or negation P and Q and R, or negation P and negation Q and R. So PDNF is the disjunction of minterms. Okay. To find PDNF, you have to construct truth table and identify where we get truth combination. There you write disjunction of minterms. That is the PDNF. And also you can find PCNF, the same process. Conjunction of max terms is the PCNF. To construct PCNF, you have to form a truth table and also write max terms. To get max terms, their combination should be false. That means their disjunction is false. So to get disjunction false, when both are false. So P or Q or R false, when P false, Q false, R false. Okay. So to get their disjunction false, you have to make negation. Negation P or negation Q or negation R. Okay. Here also, where we get true, you have to give negation, because their disjunction get false only when both PQ are false. Negation P or negation Q or R. Okay. If it is false, okay. If it is true, you have to give negation. Then you get max terms. Now PCNF of the given formula is conjunction of max terms. So you have to collect false. After rounding false, now write conjunction of max terms. Here negation P or negation Q or R, and negation P or Q or negation R, and negation P or Q or R. So PCNF is the conjunction of max terms, PDNF is the disjunction of min terms. Find PCNF from PDNF of this formula. To find PCNF from PDNF, you have to construct truth table and also find PDNF. So to find PDNF, you have to round up where you get truths. We have 4 truths. Now disjunction of these mean terms, P and Q and R, or P and Q and negation R, negation P and Q and R, negation P and negation Q and R. This is the PDNF. Now take the remaining terms disjunction, which is known as PDNF of negation. What we have remaining terms? P and negation Q and R, or P and negation Q and negation R, or next one is negation P and Q and negation R, or negation P and negation Q and negation R. Okay. These are the remaining terms. So PDNF of negation A is the disjunction of remaining terms. Now PCNF of A is negation of PDNF of negation A. Negation of PDNF of negation A is this. Now supply negation to all brackets and supply negation to each individual bracket. So and it will become R. Negation of negation P we know that it is P. By using this, you can write this. So this is called PCNF of A. Next, valid or invalid. An argument is valid when all the premises are true. The conclusion is also true. An argument is invalid when all premises are true, but the conclusion is false. To showing our conclusion is valid or invalid, first you construct truth table. This is truth table method. Now we have three variables, then eight combinations, PQR. Again, you need that negation Q, P conditional negation Q, R conditional P, negation R. So here Q, P conditional negation Q, R conditional P are premises, and negation R are conclusion. Now form a truth table. After forming truth table, you have to check where you get all premises are true. By observing in sixth row, Q is true, P conditional negation Q is true, R conditional P is true. Okay, all the premises true happened in sixth row, and then check its conclusion. Yes, conclusion also true. Therefore, it is valid conclusion. If the premises are true, but negation, but conclusion is false, then we say that it is invalid conclusion. Okay. Now, to showing consistent or inconsistent, you take their conjunction. When their conjunction is true, at least one possible situation, then it is consistent. When their conjunction is false in all situations, then it is inconsistent. Okay, to showing inconsistent, we have to construct truth table. After constructing truth table, you have to take conjunction of the premises. What are the premises? P and Q, negation P. And now you take their conjunction, P and Q and negation P. So its conjunction is false in all the situations, so it is inconsistent. If their conjunction is false in all situations, it is inconsistent. Now take another example, consistent. To consider consistent, you have to form a truth table and then take their conjunction PRQ and P. In this, you have to identify, is there any true? Yes, there is a true in first row. Okay, PRQ and P is true when P is true and Q is true. So PRQ and P is consistent only when P is true and Q is true. Thank you very much.